I finally got my USB extender cable, so camera's closer to the board. I'm going to go ahead and explain this today so that everybody's got an idea of what to do. This is all new stuff, kind of. So, okay, Wile E. Coyote. Somebody's wearing Wile E. Coyote shirt today, and I don't even know. Not here. Wile E. Coyote jumped from a desert cliff in the American Southwest to a desert highway 15 meters below, like he is in every one of those cartoons. So I underline this because that's a vertical measurement. He went from 15 meters high to 15 meters below that, which means he went down 15 meters, and that's with the y-axis. That's a vertical measurement, so I put it on y row, and it's meters, so I put it with distance. And I made it negative because he went down 15 meters. These three are the ones that we already know. I'll use purple for this. We already know on each one of these problems, it's always going to start from rest vertically. So that's our y initial velocity. So before he started to fall, he always comes off the cliff and he stops dramatically and then he starts falling after he realizes that he's in the air. But in real life, you're only doing that for a fraction of a second and then you start to fall. But you always start at zero because he comes off horizontally and then he starts to fall. We're on Earth, American Southwest, which is in Earth, on Earth. So our vertical acceleration is negative 9.81 due to acceleration due to gravity. It's going to speed up that much each second in the down direction. And horizontal velocity is 0 because gravity doesn't work this way. If it starts off at 0.1, it'll end at 0.1. That's why these are the same. It told me that right there. The horizontal velocity is 0.1, and they're the same because the acceleration is 0. Same on the x row, horizontal velocity. So, the first step with each of these is always start by solving for time. When he falls, dang. Where's my bus? Okay, here we go. When he falls, his path will go. I think I did this on video a little earlier, but the time it takes for him to fall. Boom. So from here to here, and from here to wherever it hit, took the same time. Took the same time for him to get from here to here vertically as it did for him to get from here to here horizontally. We just do both at the same time. So time is always the same as itself on x and y. So when I solve for time here, these two on every problem will always be the same. And that's why we have to do that first. Once we have time, then we can solve for this box using all this horizontal stuff, and we can solve for this box using all this vertical stuff. But like I said, like we did in the lab, these don't mix. Horizontal and vertical values don't mix. When we filled in this box yesterday, we had to use only horizontal values because this is a horizontal box. When we filled in this box yesterday, we had to use only vertical values because it's a vertical box. So we're doing a few of these today. So we got to be careful. Alright, so we'll do this one first. And we've got it. We need to use vertical values because we don't have enough on the horizontal one to find out the time. We have acceleration and velocity, but unless we know how far it went, then we can't figure out the time. So always start with vertical values. Each one of these problems is always the same. Our displacement is a vertical value. We went 50 meters down. Acceleration is negative 9.81. Velocity is 0. And we're looking for time. We're not worried about final velocity yet. We'll do that later. That has to be last. We have to do time first. And since we're not worried about that right now, we did not mention it. So we need the formula that doesn't mention final velocity. And we've got our formulas right there. This is one that doesn't mention final velocity. This one's got it. This one's got it. So I just got to plug in and then solve for time. So I negative 15 meters there. Initial velocity is 0. Acceleration is negative 9.81. And time is what I'm looking for. I need to simplify this side before I can do anything. 0 times time is 0. 1 half times negative 9.81 is negative 4.905. Zero plus this times t squared isn't going to add anything to that. So I'm just going to get rid of this 0 here. And now I've just got 15, negative 15 equals negative 4.95 times t squared. I wanted to say equals t squared, and then I want to say equals t to get my time, and then I'll be done with this part. So it says t squared times 4.95 to make that cancel, to get that out of there, so I can just get t squared. Since it says t squared times 4.95, I divide both sides by that negative 4.95. And 15 divided by 4.95, and 15 divided by 5 is 3. This is going to be a little bit more than 3. Here we go. 15. I guess it says 3.05. I'll find 3.06. It says 3.58, so I'll say 3.06. That's time squared. We need to get time. Square root of t squared is t, and the square root of this number that my calculator gave me is 1.7. This time that you get will go in both boxes. Always the time is the same on x and y. That kind of looks like 5. Let's make sure that's that. Okay. Next, it doesn't matter which one you do next. I always do this one next, just so I'm doing it the same way every time. This distance, horizontal distance one next. So I'm doing it the same way every time. I've got a routine, and I know what to do each time. So I'll do this one next. Because we've got we do have VI and VF here, but since they're the same, because acceleration is 0, if it starts at 0.1, it's not going to speed up or slow down, and it'll still be 0.1 the whole time. But because VI and VF are the same that way, I don't really need to use one of these ones with VI and VF in it. I can make this really easy for this box, and just use that as V, and this is T, and use V equals D over T to solve for that one. So let's see, I got T equals 1.7 seconds, and V equals 0.1 meters per second, and I'm looking for distance. So I got V equals D over T from my formula, and V is 0.1. D is, we're looking for displacement, and time is at 1.7. I need to multiply both sides by 1.7 seconds. Oh. No, can't do anything. 1.7 seconds. Those cancel, so it just says equals D. Since it says D divided by 1.7, that's why I multiply both sides by 1.7 to make it cancel. So 1.7 seconds times 0.1 meters per second. That's going to make 0.17. And that's the distance, so it's meters. And I can also say, I got one parentheses over here. 1.7 seconds. Because this is per second, and this is seconds on top, the seconds can cancel with the per seconds, and that leaves us meters, so we know we did it right. But if you don't want to, you can just say this is distance, and meters goes with distance, so that's my distance. Notice I used 1.7 and 0.1 for this because I'm putting this in the top row. I had to use that from the top row, that 1.7, and that 0.1 from the top row. And last, I'm going to have to do this one over here. This box over here. Now I'm on the vertical row. I'm using vertical values, so I've got to use these. And because I have 4 of them instead of just 3 like normal, I can use any formula I want for this. I'll pick it in a minute. Here we go. Acceleration is 9.81, time is 1.7, and distance is negative 15 meters. So, okay, I'm looking for final velocity. So as long as it's got final velocity, then I'm good. So not this one, but this one or this one. And if I did this one, I'd have to take a square root at the end, and that's some extra work right there. So I'm going to use this one. You can use that one, but I'm going to use this one. Just don't try to use both. Sometimes that doesn't work. Yeah, they can kind of see this. Okay, so 0.1 is final velocity. Where am I? No, it's not. I almost used the horizontal values. Yeah, let me look right here. Now I'm doing it right. Initial velocity is 0. Acceleration is negative 9.81. And time is at 1.7 seconds. So I got to do 0 plus 9.81 times 1.7. So really that's 9.81 times 1.7 because that 0 won't have anything. I got 16.7. And it's velocity, so that's meters per second. And there we go. It wouldn't have taken this long if I hadn't been talking about it the whole time. And I know these are 3 problems in one, so I don't give you all a whole bunch of these at once, I think. How many are there on this one? 4. If you don't finish